Okay guys, welcome to this week's flipped classroom video. I'm going to be doing it with a screencast this time, so it's a little different. Okay, so this week we are looking at rivers, the active river. In class tomorrow, you will be using Google Earth to examine a river. So make sure you have Google Earth on your device and bring it with you to class tomorrow. Now, so we start here in Managua, but I'm going to search for a different river because we are going to be looking at the Rhine River in this example. The Rhine River is in Europe. So while we zoom over there, I'm going to remind you of the vocabulary from section 1. The words are erosion, water cycle, tributary, watershed, divide, channel, and load. So I've zoomed into the Rhine. Here we're in Europe. I'm going to have to zoom out a little bit just to see that this is in fact Europe. So, zooming out, zooming out still. Okay, so as you can see, this is England over here, this is the Rhine, this is the Netherlands right here, Germany's over here, France is down here. Okay, so as we zoom in on the river, we can see that it is a river because it has an effect on the surface. That is to say that it is actually carved out a path into the surface, as we can see right in here. So I'll zoom in a little farther. And we can start to get a good look at this path that has been carved through the surface by the Rhine River. We can follow that path through here and eventually out to the sea. So, as the river flows downhill toward the ocean, it erodes the surface. As you can see here, the Rhine has carved a path through the European countryside. So I'll follow it again backward. This is the Rhine. We'll zoom in a little more. Here. So I follow it through the countryside. This is it over here. It continues, it continues, it continues for a long way. As here we can see it zigzagging through. Now for a second, just to see how far away we are, I'll zoom in even more to get a good look at how it has carved a path through the countryside. I can follow it, follow it, follow it for many hundreds of kilometers. Some rivers even thousands of kilometers. So we'll zoom out a little bit and we will continue. So this carving of the surface by the river is what you guys know as erosion. It is to say that the river is actually taking little tiny bits of the surface and pulling them downstream, thus carving out the path. All of these surface features that we see here have been carved out by the flow of fresh water. It's all erosion. So, can you name the 3 factors that affect the rate of erosion for a river? Well, if you said gradient, discharge, and load, then you are correct. But perhaps you should look at page 73 to see what these words mean exactly. Now, when we look at this river, we can also see that there are many other rivers that join in with this river. So we'll zoom in right here and see if maybe we can see some of them. Yes, right here. This is another river. And if we follow that river, right here, we will see that this river joins in to the main river. So I go upstream. Here, if you remember the oxbow effect, we can see the path that the river used to be taking zigzagged, but now it flows straight through. Go up here, we can see a major tributary here. It is flowing in and joining into the Rhine. Now, this is pretty zoomed in, so if we zoom farther out, we can see that there are a lot of them. This is one. This is an important one for the German economy. The Mainz. If we come up here, we'll see another one. I believe here is called the Ruhr River Valley. All very famous. So all of these are tributaries that add water to the river. Now all of these tributaries that flow into the river, actually all water that flows into a river is called the watershed. So the watershed is this entire area. It's a geographic area that defines the limits of the water that flows into the river. So for the Rhine, it's probably an area, all of this, any water in this area here will find its way eventually into the Rhine, and then will flow out into the North Sea here at the delta. So the border of this watershed is known as the divide. That is, that it divides the Rhine's watershed from other watersheds. There are many rivers in Europe. If we go farther north, we'll come to a new watershed. Perhaps the Elbe here. There are some smaller ones up here. If we go south, we'll come to the, I believe it's the Seine, is the river that flows through Paris. Down here there are other watersheds, but anyway, the divide is what separates one watershed from another. On page 72 in your book, there's a good picture of the Mississippi in its watershed with the divide that separates one half of the continent from another. Now the channel, another vocab word, is just the route that the river has carved out. So if we zoom back in a little bit, the channel is just what becomes apparent of the river. This right here. Now, for these rivers in Europe, the channel and the river just are the same thing because it's always full of water. But here in Nicaragua, you may have noticed that in the dry season, a lot of streams also dry up. The water is no longer there, but the channel is still there. That is to say, the dry place where the water used to flow is just the channel. When it has water in it, it's now also a river. Okay, and finally, load describes the amount of soil that is in the river. So if we zoom in, sorry, we'll go to the end first. See where the Rhine starts. Up here in the Swiss Alps. So we'll center on here and we'll zoom in, and we will see that and up here in these mountains, if we zoom all the way in and look at the river, if this will resolve so we can get a good look at it, we will see that the river is kind of a bluish color. It's the color you would expect a river to be, right? Bluish, whitish. Doesn't look too dirty though, right? That's because the river hasn't had enough time to collect a lot of dirt. It just started. It's high up in the mountains near its beginning. So it doesn't have a lot of load. Its load is small. Now if we zoom out, away from the river, so we can get back over here to where it flows into the ocean, and then zoom in on it again after it has had thousands of kilometers to flow across the countryside, erode away the surface and pick up dirt, and we look at it again, we can see that, well, it's still kind of blue, but here, you can see this is the load. This whitish brownish color that has been added to it. You can also see there's a whole lot of agriculture going on around here now because that load is very fertile and it has made the ground very fertile as well. So it's actually a really good image of the differences in loads and rivers on the Amazon. So I'll go to Rio Negro, Amazon, and let it take me there. So this is the Amazon. This is the Rio Negro. As you can see, it's black, which is why it's called the Rio Negro. This is the Amazon. As you can see, it has a lot of dirt in it. It has been eroding away for thousands of kilometers already, and it is full of dirt. Here is where the two rivers meet. The Rio Negro is a tributary of the Amazon. So as you can see, the two rivers are very different colored. This now is the Amazon. However, the two rivers continue for kilometers downriver, mixing together. The water that was in the Rio Negro, water that was in the Amazon, they don't just automatically mix and form a new color. They slowly mix together over time. This is because each river had a different load. That is to say, it had different kinds of soil particles in it. And then, a couple 10 or 15 kilometers downriver, it's finally pretty much all mixed together and has a lot of soil particles in it again. Okay, so how do you think the size of the soil particles in the load affect the rate of erosion? That is to say, if there are big particles in the river, will it erode the ground faster? Or if there are smaller particles in the river, will it erode the ground faster? And finally, a river can be described in 4 ways. There are youthful rivers. That is a river that is young or has just started. There are mature rivers. That is a river that has recently started and has pretty much developed its boundaries. Then there are old rivers. All of the rivers that we will be looking at are old rivers. It has solidly established its channel. It's probably not going to change much anytime soon. It is how it's going to be, so it is known as an old river. But then sometimes there are rejuvenated rivers. These are rivers that, because of some kind of tectonic activity, have a sudden change in direction. And then they start carving through new ground. And they go through the process of being a youthful, mature, and old river again. Okay, so tomorrow in class you will be using Google Earth to draw a river and its watershed. That means all the tributaries as well. So you can see for the Amazon you would be drawing the route of it and all of these tributaries, and then you would also be putting the border around the watershed. And you will also be describing many other factors that I have shown you in this video, and some more that you should be able to get from your book or from common information online. So we'll see you in class tomorrow, ready to talk about rivers.